Hello everyone, welcome back to day 7 of our Python complete course. If you have completed the first 6 days, congratulations, you have already learned Python. Basics, variables, operators, strings, conditional statements, loops, functions, and now it's time to level up your Python programming skills. Today we are going to learn some of the most powerful concepts used by professional Python developers. Recursion, map function, filter functions, and reduce functions, and lambda functions. These topics help you to write cleaner, shorter, and more efficient code. They are also commonly asked in coding interviews and frequently used in data science, automations, and real-world Python projects. Don't worry if these terms sounds difficult right now. By the end of this video, you will understand every concept step by step with every simple examples, diagrams, coding practice, and interview questions. And I am also giving you one mini project at the last of this video and 5 to 6 homework question and 5 to 6 practice question. We'll also solve practice problems so you can build confidence while coding. I recommended that you don't just watch video, open your code editor and type every program by yourself. Programming is a practical skill, and the more you practice, the faster you will improve. If you are new in this video, if you are new in this series, make sure you start from day one because every lesson builds on the previous one. So grab your laptop, open VS Code or any Python ID and get ready to learn some of the most exciting Python concepts. Let's begin day 7 and master recursion, lambda function, map function, filter function, and reduce function. Let's start coding. Let's go to computer screen and start our Python day 7 of our coding series. Hello everyone, welcome back to day 7 of our Python complete series. I hope all of you are practicing the program from the previous classes because programming is not something you can learn just by watching videos. The real learning happens when you write the code you by yourself. Before we start today's lessons, let's quickly revise what we learned in day 6. We learned about functions and understood why functions are one of the most important concepts in programming. Instead of Instead of writing the same code again and again, we can write it once inside a function and reuse it whenever we need it. This makes our code clean, organized, and easy to maintain. Then we learned about parameters and arguments. Parameters, argument. Remember the difference. A parameter is a variable written inside the function definition. For example, it look like this: def. It look like the def greet name. Here name is a parameter. When we call the function greet Sangam, Sangam becomes the argument. After that, we discuss the return statement. A return statement sends a value back to the place where the function it was called. Now, the function return. Then we explored different kinds of arguments. We learned about default arguments, keyword argument, variable length arguments using single star args and keyword variable length arguments using double star args. This helps us make flexible functions that can accept different kinds of inputs. Finally, we learn about scope. A variable created inside a function is called a local variable. It exists only inside the that function. A variable created outside the function is called a global variable. It can be accessed from different parts of the program. We also saw how the global keyword allows us to modify a global variable inside a function. So if you have understood all of this concept, you are ready to for today's class. Today's session is very exciting because we will move on one step closer to write professional Python code. Today we will learn recursion, where a function call itself, then lambda function, small one-line function, anonymous function, function without a name, map function to apply a function to every item in a collection, filter function to select only the elements that satisfy a condition, and reduce function to combine multiple values into a single result. These concepts are widely used in Python interviews, data science, machine learning, automation, backend development, competitive programming. Many beginners feel these topics are difficult, especially recursion and lambda function. But don't worry. In this video, we will understand every topic from scratch using simple example, diagrams, and plenty of coding practice. By the end of today's class, you will not only understand this concept but also know exactly when and why to use them. So keep your code editor open, pause the video whenever necessary, write every example yourself, and try changing the input to see how the output changes. Learning by doing is the fastest way to master Python. So without wasting any more time, let's start with our first topic, recursion. Our first topic is recursion. Now let's move to our first and one of the most interesting topics of today's class, recursion. Many beginners think recursion is one of the hardest topics in Python. But once you understand the basic idea behind it, it becomes much easier. So let's understand recursion from scratch. First, what is recursion? What does the recursion word mean? Recursion is a program technique where a function calls itself to solve a problem. I write here also where a function calls itself. Normally, we call one function from another function. Here, the function is called, I am giving one example here, like this. Here, the function is called from outside, but in recursion, the function calls itself. That means the same function keeps executing repeatedly until a specific condition tells it to stop. So its definition is recursion is a technique where a function calls itself repeatedly until a stopping condition called the base case is reached. I am writing definition in note section. I am going here and word wrap. Here, this is the definition of recursion. The most important part of recursion is the base case. Without it, recursion will never stop. Basic syntax of recursion is look like that. Basic syntax of recursion, it looks like that. That's it. The function is calling itself. Now let's think when the function starts, it reaches function. So it calls itself again. The new function again reaches function and then call itself again and again. This process never ends. So if we execute it, function, Python will continue creating new function call forever. Eventually, Python says I cannot keep creating more function call. Then it throws an error called recursion error. Example, first example is recursion, infinite recursion. Let's see an example. I write here def hello, then print hello, then hello, one more time, hello. Here. Let's understand what happens. First, hello is called inside it. Python prints hello. Then it reaches hello, so it calls the function again. Now the second function prints hello. Then it again calls itself. Again. The output becomes hello, hello, hello. It looks like that. Here, hello, and gives a recursion error, maximum recursion depth exceeded. Why? Because every function call is stored in memory. Python has a limit on how many recursive calls can exist. Once that limit is crossed, Python raises recursion error. Why do we need a base case? So how do we stop recursion? We use something called the base case. A base case is simply a condition that tells the Python stop calling it yourself. I am giving you the definition in notes section. This is the base case definition. Without a base case, recursion becomes infinite. Think of it like climbing stairs. If every stair leads to another stair forever, you will never reach the destination. The base case is the final stair where you stop climbing. Example with base case like that. Example with base case. Now look at this program. Let's understand it carefully. We call count 5. First n is 5 and is n equal to 0? No. So Python prints 5. Then it calls count 4. Now it n becomes 4 again. 4 is not equal to 0. Python prints 4. Then calls 3 again 3. Then 2. Then 1. Finally count 0. Now the condition in n equal to 0 becomes true. So Python executes return. The function stops, no more regressive calls happen. The output becomes 5 4 3 2 1. Here, what is the okay? Here, 5 4 3 2 1. Visualizing the recursive calls. Let's visualize the flow. When we write count 5, Python does this count 5, then count 4, count 3, count 2, count 1, count 0, and stop. Notice something important. The function keeps moving towards the base case. Every recursive call reduces the value of n. Eventually, it reaches 0 and recursion stops. If we forget to reduce n, the function will never reach the base case, then again recursion error. Like real life example is, let's understand recursion using a real life example. Imagine you have a 5 books stacked on a table. To reach the bottom book, you remove the top book first, then the next, then the next, then the next. Finally you reach the last book. Recursion works similarly. It solves one small part, then another until the smallest problem is reached. Factorial using the recursion. Now let's solve one of the most popular recursion problem, finding the factorial. Factorial using recursion. First, what is factorial? Suppose we want 51. It means 5 into 4 into suppose we want 5 factorial here. It means 5 into 4 into 3 into 2 into 1. And the answer is 120. Similarly, 4 factorial, the answer is 4 into 3 into 2 into 1. Now, observe carefully 5 factorial here. 5 factorial equal to 5 into 4 factorial. Here, 5 factorial equal to 5 into 4 factorial. And 4 factorial equal to 4 into 3 factorial and 3 factorial equal to 3 into 2 factorial. Can you see the pattern? Every factorial depends on a smaller factorial. This makes recursion perfect for solving factorial. The factorial program look like that, like def factorial n. Oh, sorry, def factorial n if n equal to 1, return 1. Return n multiplied factorial n minus 1. Then print factorial 5. Here, what happened? If I run this code, it will print 20. Factorial 5 equal to 5 into factorial 4. And then 5 into 4 into factorial 3. Then 5 into 4 into 3 into factorial 2. Then 5 into 4 into 3 into 2 into factorial 1. And the factorial 1 value is 1. Now, so Python starts calculating backwards 2 into 1, 3 into 2, 4 into 6, and 5 into 24 equal to 120. And final answer is 120. Notice something, recursive calls go down until the base case. Then answer comes back up. This is one of the most important concept in recursion. And one more thing is Fibonacci using recursion. Fibonacci using recursion. Now let's solve another famous interview question, the Fibonacci series. Remember the series 0, 1, 1, 2, 3, 5, 8, 13, 21. Every number equals previous number plus previous number. Now look at the program of Fibonacci series. It looks like that. Output of this series is Fibi. Wait for a second. Suppose we calculate Fib 5. Then what is the error of this? Python Fibonacci series. What is a def and less than 1? Wait for some time. It's correct. Then it's correct. It's correct. Okay. Here. Then return. Wait for some time. It forgot. Oh, sorry. I write. I want to write here print. Hmm. And then, it prints Fibonacci series here. It prints 0, 1, 1, 2, 3, 3, 3, 5, 8, 13. Let's print Fibonacci series of 3 here. Python needs Fibonacci series of 5. Then I repeat. Okay, first I expand this Fibonacci series of 5. 0, 1, 1, 2, 3. This creates many repeated function cell calls. That's why Fibonacci recursion becomes slow for large numbers. Later, when you learn dynamic programming or memoization, you will see how to optimize this. And what is recursion used? Where is recursion used? Many students ask, Sir, why should we learn recursion? Bhaiya, why should we learn recursion? Because recursion is used in many advanced computer science problems. For example, traversal. Every folder inside your computer contains more folders. This is naturally recursive. Graph algorithms, backtracking problems, divide and conquer algorithms. Advantages of recursion. Let's quickly summarize the benefits. Cleaner code, many complex problem becomes much shorter and easier to understand. Perfect for recursive structure, useful in advanced algorithms, and many more things. Let's move to next topic, lambda function. First remove all of this and lambda function. Now that we have learned about recursion, let's move to another very useful Python concept, lambda function. If you have ever felt that writing a complete function for a very small task is unnecessary, then lambda functions are the best perfect solution. They allow us to write small codes in just one line. Don't worry if you have never heard of them before. By the end of this session, you will know exactly what lambda functions are, why they are used, and when you should use them. What is lambda function first? A lambda function is a small anonymous function written in a single line. I write here also. Lambda function is small one line function. I write full definition here. Now, there are two important words here, small and anonymous. Let's understand both. A lambda function is a design for simple operations like adding two numbers, finding the square of a number, checking if a number is even, and similar short tasks. The second word is anonymous. Anonymous means without a name. Normally, when we create a function using the def keyword, we give it a name. For example, def greet print hello. Here the function's name is greet, but lambda functions don't need a traditional name function definition. They are created as expressions and are commonly assigned to a variable or passed directly where needed. That's why they are called anonymous functions. Why do we need lambda functions? Many students ask. If we already have functions, why do we need lambda? That's a very good question. Imagine you only want to calculate the square of a number once. Using a normal function, you would write def square x, return x into x. This takes several lines. Now imagine you only need this function for one small task. Instead, Python lets us write the same logic in a single line. That's exactly why lambda function exists. They make the code shorter and cleaner. Normal function versus lambda function. Let's compare both. Normal functions look like this for square. Here, here we use the def keyword, we write the function name, we use return, we write multiple lines. And now at lambda function, it looks like that. Square lambda x that. Output both of them is 25. Here I write print square 5, 25. If we use this only, then it prints 25. If we use this, then it also prints 25. At first glance, this may look confusing. Let's break it down. Understanding the syntax. The syntax of lambda function is lambda parameters expression. This is lambda, this is lambda parameters and expression. There are only three parts. Lambda, this tells Python that we are creating a lambda function. Parameters, these are the input values. In our example, lambda x, the parameter is x, just like a normal function. And third is expression. Everything after the colon is the value that will automatically be returned. Notice something interesting. There is no return keyword. Python automatically returns the result of the expressions. So lambda x x into x multiply takes a value of x, multiply it by itself, and then return the answer. Calling the lambda function, we assign the lambda function to a variable named square. Square Now square behaves just like a normal function, so when we write print square 5, Python replace x with 5, it calculates 5 into 5 25. Very simple. Adding two numbers. Now let's create a lambda function with multiple parameters. It will look like that. First comment out this, run this. Output is 30. Here A becomes 10, B becomes 20, the 10 plus 20 is 30. Can lambda function have multiple lines? The answer is no. This is one of the biggest limitations of lambda function. This is valid, but this is valid only one line. A lambda function can contain only one expression. If your logic requires multiple statements, loops, or conditions that span several lines, you should use the normal function with depth. Normal function use the def keyword can have multiple lines of code, can contain loops and multiple statements, better for large programs. Lambda function written using the lambda keyword, always a single line expression, automatically returns the result, best for short and simple operators. I'm giving you difference that. This is the normal function. This is the lambda function. Why are lambda function useful? Now the important question. Why do programmers use lambda function? There are several reasons. Shorter code, instead of writing 4 or 5 lines, we can complete the same task in one line. Easy to read and for small tasks, useful for with built-in functions. Great for temporary functions. Limitations of lambda functions are only one expression, not suitable for complex logic, less readable for beginners. Now move on to next topic, anonymous function. Now this topic is actually very easy because you have already learned main concept in the previous section. In fact, lambda function and anonymous function are closely related. Many students think they are two different concepts, but that's not true. Let's understand why. What does anonymous function mean? In simple English, anonymous function without a name. For example, when someone donates money without revealing their identity, we call it an anonymous donation. Si- Similarly, in programming, an anonymous function is simply a function that does not have a traditional name. That's all. Can we use the anonymous function without storing it? Here, add lambda a plus b. Here we are creating a lambda function and storing it in a variable called add. The important point is that the function itself is still anonymous. The variable add is just a reference to that function. This is why lambda functions are called anonymous functions. Can we use anonymous function without storing it? Now here's something interesting. In the previous example, we stored the lambda function inside a variable. For example, square lambda x into x. But what if we only want to use functions one time? Do we really need to create a variable? The answer is no. We can create the function, call it immediately. Let's see how. First example of anonymous function. First remove this anonymous function. This is the anonymous function. The output of this is 15. At first glance, this looks confusing. Let's understand it step by step, breaking it down. Lambda x plus 10. This creates a lambda function taking x, one parameter x, and return x plus 10. But notice something after the closing bracket 5. That means we are immediately calling the function with the value 5. So Python internally thinks like this: x equal to 5, 5 plus 10, answer is 15. The function is created, used, and then discarded. We never give it a name. That's why it is called an anonymous function. Why use anonymous function? Now the important question. If we can simply create a normal function, why do we need an anonymous function? There are several reasons. Temporary work, cleaner code, useful with built-in function like map, filter, reduce, real life and logic for this is let's understand anonymous function with real life example. Imagine you need a calculator only once to calculate 25 into 8. You open the calculator, calculate the answer and close it. You don't need the calculator open forever. Anonymous function work in a similar way. They are created, used once, and then you are no, there are no longer needed. And then move on to the next topic, map function. Map function. This is a function that you will see very often in Python, especially in data science, machine learning, automation, and personal programming. The good news is that if you have understood lambda function, learning map function will be very easy because they are often used together. Let's understand it from the beginning. What is a map? Imagine you have a list of numbers and you want to perform the same operation on every element. For example, suppose you have numbers n equal to list of number 1, 2, 3, 4, 5. Now, you want to double every number. One way is to use a for loop and like this for num in and result dot append and num multiplied 2 print result. It works perfectly, but Python provides a much shorter and cleaner way, that is the map functions. So the definition of the map function in map function applies a function to every element of an iterable and returns a map object containing the transform values. I am giving you notes here. Map function definition. What is an iterable? Before learning the syntax, let's understand one important word, iterable. An iterable is any object that can be looped through. Example include list, tuple, string, set, dictionary, it keys by default. Dictionary, its keys by default. So whenever you hear the word iterable, simply think a collection of multiple values. Syntax of map. The syntax is very simple. Map round bracket in under function comma iterable. There are only two parts. First argument function. This tells Python what operation to perform. It can be a normal function, a lambda function, a built-in functions like int, string, float, and second argument iterable. This is the collection of values map function will perform the same operation on every element inside it. Double every element. This is we have to double every element. Numbers equal to 1, 2, 3, 4, 5 list. We write here result equal to map lambda x colon x multiplied 2 comma n. Then print list result. When we run this code, it will print exactly the double of all the numbers. Why do we use list function? You may have noticed something. We wrote print list result instead of print result. Why? Because map function does not immediately returns a list. It returns a special object called a map object. To actually see the values, we convert it into a list. That's why we use list result. If you print result directly, you will get something like this map object at this code. So whenever you want to display or store all the results, convert the map object using list function. Now, the second example is convert strings into integers. First, I am taking this. This look like numbers, but there are actually strings. How can we convert all of them into integers? Using map function. I write here result map int nums and then print list result. The output is 1, 2, 3. Here, instead of using a lambda function, we directly pass the built-in function. Int Python internally does the int1 into int1, then int7 to 2 int2 to 2, then int3 to 3. This is one of the most common uses of map function. Where is this used? Suppose the user enters numbers like this 10, 20, 30, 40. If we write input dot split, we get in a string form. To convert them into integers quickly, programmers often write numbers list map int and then input split. This is very common interview and competitive programming pattern. Let's break it down. Input takes user input here and dot split separates the value. Map int converts every string into to an integer. List creates the final result. Very powerful. You will see this line in many real Python programs. S- Example 3. Square every number. Now let's create another example. I am giving it a homework. You have to create using map function and lambda function. You have to do square of every number. Then move to next topic, filter. Filter function. In the previous session, we learned about map function. Remember what map function does? It performs an operations on every element in a collection and returns the transform values. For example, if we multiply every number 2 by 2, every element changes. But if we don't want to change every element, what if you only want to select some element? For example, only even numbers, only students who passed, only employees with salary greater than 50,000, only names starting with letter A. This is exactly where filter function becomes useful. What is filter function? Filter function returns only the exam elements that satisfy a given condition. This is the definition of filter function. Unlike map function, filter function does not modify the data. Instead, it checks every element and keeps only those for which the condition is true. Think of it like a security guard. Imagine 10 people are standing in a queue. The security guard checks everyone's ID. Only people who satisfy the rules are allowed inside. Similarly, filter function checks every element one by one. If the condition is true, the element is kept. If the condition is false, the element is removed. Syntax of filter function it look like that. This contains like the condition usually. We write a lambda function that returns either true or false iterable. This is the list, tuple, or any collection whose elements we want to check. Example of filter function is even numbers only. Like I am writing here numbers equal to 1, 2, 3, 4, 5, 6. Then even, then print list even here. The output is 2, 4, 6. Let's understand it step by step. We have the list 1, 2, 3, 4, 5. Now Python starts checking each number for 1 modulus of 2 is equal to 0 false. So 1 is discarded. 2 modulus 2 equal to 0 true. So 2 is kept. 3 is discarded. 4 is kept. 5 is discarded. And 6 is kept. The final output is 2, 4, 6 list. Notice something, we never changed the numbers, we only selected the ones that satisfied the condition. Why do we use list? Just like map function, filter also returns a special object called filter object. It does not immediately return a list. So it to display all the values, we convert it into list. Print list event. If you print the filter object directly, you will see something similar to filter object at 0x, like I am showing you here. Directly filter object, it will looks like that. Filter at this code. That's why we use filter list. I am giving you one task. You have to calculate numbers greater than 10. You have to create a list any number 4, 15, 9, 20, and then filter with number greater than 10. And I am giving one more homework. You have to create a name list. Like in name list, you write Naman, Raj, Ankit, Rohit, anything, and filter that name starting with A. And now move on to next topic, reduce function. Now we have reached the final functions programming concept of today's class, reduce functions. So far, we have learned the three more powerful concepts, lambda function, map function, filter function. Let's quickly revise them before learning reduce function. Map function changes every element, filter function select only the elements that satisfy a condition. Now you may wonder, what if I don't want another list as the output? What if I want just one final answer? For example, find the total sum of all numbers, multiply all numbers together, find the largest number, find the smallest number. Instead of getting another list, we want one final value. This is exactly what remove function does. What is reduce function? Reduce function perform a commutative operation on the elements of an iterable and reduce them to a single value. I am giving you notes here. Reduce function definition. The word reduce means to make something smaller. Imagine you have a list of 100 numbers. After applying reduce function, you don't get another list. You get only one final answer. That's why it's called reduce. Why do we need to import reduce function? Unlike map function and filter function, reduce function is not a built-in function. It belongs to a Python tools, function tools module. So before using it, we must import it. From func tools import reduce. If you forget to import it, Python will show an error. So remember, always import reduce function first. Syntax of reduce function is like that. First remove all of them. Reduce function. Syntax of reduce function is like that. There are two parts. Functions. Usually we use a lambda function with two parameters. Iterable the list tuple or a collection whose value we want to combine. How does reduce function work? This is most important part. Many beginners memorize reduce function without understanding it. Let's understand the logic. Suppose we have 1, 2, 3, 4. Reduce function takes the first two elements 1 and 2. Applies the function. Suppose the function is addition. 1 plus 2 equal to 3. Now this answer becomes the new first value. 3 and 3. Again 3 plus 3 equal to 6. Now 6 and 4 equal to 10. No elements are left. Final answer is 10. Notice something, reduce function keeps combining values until only one value remains. Example of reduce function. First, sum of all numbers here. Let's first import the reduce function here. Then numbers equal to 1, comma 2, comma 3, comma 4. Then I write here for reduce function and then print result. Output is 10. I'm giving you one question. You have to multiply this number. I'm showing you solution, but you have to multiply. You have to just only remove plus and then add this, multiply this. This is 24. I'm giving one task. You have to find largest number between this. This is simply 1, 2, 3, 4. You have to write another list like 4, 9, 1, 15, and anything and find largest number. Real life example of reduce function. Imagine your teacher asked the class to calculate the total marks of four tests. Marks are 10, 20, 15, 25. Instead of writing all the numbers separately, you start adding them one by one. 10 plus 20 equal to 30, 30 plus 50 equal to 45, 45 plus 25 equal to 70. Finally, you have one total. This is exactly what reduce function does. It combines multiple values into one final result. Map function, filter function, and reduce function. Now let's compare all three functions together. Map function transform every element purpose and output a new iterable with the same number of elements. Filter function purpose selects elements that satisfy a condition, output a new iterable that may contain fewer elements. Reduce function purpose combines all elements into one result, output a single value. Advantages of reduce function is short code useful for aggregation and work well with lambda function. Limitation of reduce function can be built for difficult for beginners, not always the most readable. Where is reduce function used? Although you will see some and parentheses, maximum parentheses, and minimum parentheses. So many common tasks. Reduce function is valuable when you need to repeatedly combine values using your own logic. For example, combining multiple strings into one sentence, calculating the product of all numbers, like that. Quick revision. Let's summarize everything we have learned about reduce function. Reduce function performs commutative operations. It combines all elements into one final value. It must be imported using from func tools import reduce. Syntax of reduce functions is this. It is commonly used for some product maximum minimum other custom aggregation tasks. You congratulations, you have successfully completed all the concept of day 7. Today we learned some of Python most powerful functional tool programming concept. Let's quickly revise everything before moving to our practice question. We learned recursion, lambda function, anonymous function, map function, filter function, and reduce function. And I am giving you some tasks. You have to do it in your homework. Here, I am giving you some tasks, practice questions. Practice question. First, write a program to find the factorial of a number using recursion. You have to do it by yourself. And second practice question is print the numbers from 10 to 1 using recursion. Third practice question is lambda function to calculate cube. And fourth is use map function to square every number. And fifth cost practice question is use filter function to print all odd numbers. And the sixth and last practice question is use reduce function to find the product. I am giving you some homework questions also here. Homework questions here. First question is reverse a string using recursion. Second question is find the sum of digits using recursion. Third question is create a lambda function to check if a number is positive. Fourth question is use map function to convert a list of temperatures from Celsius to Fahrenheit. Fifth question is use filter function to print only prime numbers from a list. Sixth question is use reduce function to find the maximum value in a list. And seventh question is build a mini project that process employee salaries using map function, filter function, and reduce function. And that's it. And you have to make one mini project. I am giving you solution also, but you have to try by yourself. Mini project. Oh, in here you have to develop student marks processing system. Here you have to import from func tools, import reduce marks 45, 67, 89, 34, and 76. And then you have to print original marks, then passed equal to list filter lambda x colon x greater than equal to 40 comma marks print passed comma passed. Then you have to bonus also right here bonus list map lambda x plus 5 passed Then you have to write here print bonus, comma bonus, and then total. Total equal to reduce lambda a comma b a plus b comma bonus. Print total total. This you have to create this students marks processing system. This is your mini project. First you try it by yourself, then see the answer. Okay, goodbye.